Right, so let's go through this 2018 O-level question. So I have this marathon, right, running a long distance race of 42 kilometer, water on the skin, evaporates as it runs. So state two differences between evaporation and boiling. So this one is quite simple. The first difference is that evaporation occurs at any temperature. The boiling occurs at only fixed temperature. Number two is that evaporation occurs only at the surface of liquid, whereas boiling occurs throughout the liquid. Okay, for part B, data relevant to the marathon is given. Okay, so we are given some data. Mass of marathon is marathon runner 70 kg, time is 3.5 hours. Then average production of thermal energy in 1 hour is about 3.2 times 10 to the power 6 joules. Number two is that the average loss of energy in 1 hour by evaporation is 2.3 times 10 to the power 6 joules. Okay, the last two is average specific capacity of the human body is roughly 3,500 joules per kg per degree Celsius. So for this value, right, what does it mean to be 3,500 joules per kg per degree Celsius is that in order to raise 1 kg of body by 1 degree Celsius, you will require to supply about 3,500 joules of heat energy. Last but not least is the LV. So LV, right, latent heat of vaporization of water at body temperature is roughly 2.4 times 10 power 6 joules per kg. So for this LV, the definition is you need to use 2.4 joule times 10 power 6 joules of heat energy to raise 1 kg of water, to vaporize 1 kg of water from water state to gas state. Okay, so that is the data. Okay, so let's do the part I. So calculate the mass of water lost by evaporation in 1 hour. So based on this context, we simply just use Q to MLV because the one is the mass of water lost by evaporation. So okay, the Q, you must use the energy lost by evaporation, which is 2.3 times 10 to the power 6. M is something that we want to find. LV is the 2.4 times 10 to the power 6 joules per kg. So in 1 hour, you actually lost about 0.958 kg of water via the skin. Okay, part 2, assume that the runner only loses energy by evaporation, right? Calculate what is the rise of his body temperature in 1 hour. So same idea. Let's go back to the data. So if you look at the data, you produce about 3.2 times 10 power 6 joules of energy in 1 hour, but you only lose 2.3 times 10 power 6 joules of energy or heat energy via the evaporation process. So in 1 hour, you actually gain a 0.9 times 10 power 6 joules of heat energy. Then next part will be, we want to calculate what is the delta T, right? So delta T, we will need to use something known as Q equal to MC delta T. So next part, information, we need to use 3,500 joules per kg degree Celsius. So the mass is given to us right here, 70 kg. So it's simply just sub in. So for example, right, Q equal to MC delta T. So Q, this is the net gain. All right, M is the mass of the runner, and C is the specific capacity of the human body lah. So 3,500. So if you calculate correctly, in 1 hour you will have a gain in temperature of 3.67 degrees Celsius. Okay, part 3. Using your answer, right, show that the evaporation from skin is not sufficient to prevent overheating during the race. So in 1 hour, you actually gain your temperature is roughly in 1 hour your body temperature is roughly 40.67 degrees Celsius, which is already more than 40 degrees Celsius, which will cause overheating. Okay, part 4. One other mechanism that for evaporation occurs in your breathing, where water is vaporized in the lung and then exhale. So the key thing about this question is this second statement. Assume that there is no increase in the runner's body temperature during the race, meaning that the gain is equal to the loss. So the gain by the body, gain of heat by body is equal to loss of heat via evaporation by skin plus loss of heat via breathing. Okay, so you can see, right? Okay, so this part, the loss of heat via breathing give me roughly 0.9 times 10 to the power 6 joules. Okay, because there shouldn't be any gain in temperature. So meaning that whatever gain of heat energy I have via the body must be equal to the loss of heat via evaporation by skin and loss of heat via breathing. So same thing, we will need to use, because there's no gain, right, in temperature, means I need to use Q equal to mLV. So Q is 0.9 times 10 to the power 6. M is the mass of water. Then I want to calculate LV is, okay, let me just go back, 2.4 times 10 6. Okay, so let's determine the mass is equal to 0.9 times 10 divided by 2.4 times 10 to the power 6. So this will give you roughly 0.375 kg. But this is only for 1 hour. Don't forget, they want the whole race, right? So the whole race takes roughly about 3.5 hours. So the total mass, 375 multiplied by 3.5. So this will give you about 1.3125 kg. So just give them 3 SF, 1.31 kg. Okay, the last one will be, assume that the runner, right, does not drink any water during the race. So based on my answer on BI and B part 4, determine the level of dehydration at the end of the race. So the water lost by evaporation throughout the race. So because I calculated in the BI, right, that 0.958 kg is in 1 hour. So this is the water loss via the evaporation, right, by the skin in 1 hour. You multiply by 3.5 hours. So this will give you 3.353 kg. So the total water loss, okay, you need to add on this 1.31 or 1.3125. So 1.3125 plus 3.353. So this will give you, let's see, plus 3.353. Okay, so you will lose a total of roughly 4.6655 or roughly 4.67 kg of the water throughout the race. Next, you want to determine what is the percentage loss of water with regards to its human body mass. So let's determine. So 4 divided by 70 times 100. Okay, so he lost about 6.67% of his body mass. So you can see, let's go back to the table. So the level of dehydration is more than 5%. Then after that, he will undergo severe dehydration. So that is how we solve this question.